Good morning, everyone, and thanks for joining our Clallam County EDC Coffee Chat, Coffee with Colleen. We are really happy to have Kyla Westphal, the Vice President of External Affairs for Ebb Carbon, join us today. And she does have a presentation that she'll be providing us. If you all wouldn't mind, though, before we get going, if you'd put yourself on mute and try to keep yourself on mute so that we don't inadvertently hear any puppies or kids or spouses and the like, or toothbrushes. Uh, so we had that happen this morning. It was fun. Anyway, yeah, so if you'll do that, and if you have any questions for Kyla, she'd be happy to answer them. We like this to be interactive. So if you would just raise your hand and we'll call on you. Alternatively, if you would like me to ask your question, you'd prefer to put it in the chat, you can do that and I'll go ahead and ask your question. So Kyla, thanks so much for joining us this morning. And we're excited, and we're not only excited to hear about Ebb Carbon, but the innovation and the sustainability aspects, and that you selected Clallam County is really terrific, and we appreciate that. So if you want to take it away, please do.
All right, let me get my slides geared up here. Can you see that, Colleen?
Sure can.
Okay, great. Well, thank you so much for having me this morning. I have my coffee. I'm all set to go. I really appreciate your time. What a lovely tradition to start your Wednesday morning with. As Colleen mentioned, my name is Kyla. I am the VP of External Affairs with Ebb Carbon. I do have, I don't know, this is probably about a 30-minute presentation. I'm happy to take questions as we go if they're burning, and happy also to take them at the end. So with that, let me get us rolling here. So before I dive into all of the, kind of the technology and the sustainability aspects, I did just want to take a moment to introduce myself, so you can kind of get a sense of the person behind the screen here. I really started my career working for a U.S. Senator in California. And my job there was to meet with constituents, hear what's on their mind, their concerns, voice their priorities. And since then, I've spent about 15 years really working on climate solutions. And I share those bits because they're really kind of dots on my journey that directly connect to the work that I do today with Ebb Carbon. And that's really about listening to, working with communities to help shape how Ebb Carbon designs and deploys its technology. And for me, I'm sharing an image here of my time living in the Pacific Northwest during COVID. I actually lived on Orcas Island for a year. That's my daughter in the photo there, to share, my personal connection to this place. While probably a flash in the pan for a lot of you who have lived here for decades or generations, it's a really special place for me personally. And I share that image of my daughter. She's 6 now. It's hard to believe. She looks like a little baby there. But just to say, I also do this work for deeply personal reasons. And it means a lot to me. And I'm here representing Ebb Carbon. We are a climate and ocean health company. And you can see our team here outside of our headquarters. And we're really oriented around mitigating climate change and making a positive impact on ocean health. So we really have a twofold mission, and I'll get much deeper into how we do this. But first, removing excess carbon dioxide from the air, and I'll explain why we see that as a big problem, or a big solution that needs to be introduced into the world, and deacidifying the ocean, which is an unfortunate consequence of excess CO2 in the air. And we're really focused on working with the ocean to achieve these objectives. And I'll also explain that in a little more detail. But first, I always like to take a moment to try to kind of wrap our heads around, like, carbon dioxide removal, why are we even talking about this, right? I don't think it's necessarily intuitive that we would need to be removing carbon dioxide from the air. A lot of the talk and a lot of the work that I've done in previous roles and iterations in my career has been about the emissions. So this bathtub you're looking at is meant to represent the atmosphere, right? In the tub is all the CO2 in the atmosphere. And of course, emissions are what are raising the water level of the tub. And we've been doing a lot of work to turn down those taps, turn down those emissions taps. In fact, I was reading today that for the first time last year, wind and solar produced more electricity than coal, as an example. We are making progress. The unfortunate fact is we're not making progress fast enough. And so that's where carbon removal comes in. That's like pulling the plug out of the bathtub and kind of draining it, right? And there is scientific consensus today that we need to remove on the order of 5 to 10 gigatons, which is a billion tons of CO2 every year by 2050 in order to prevent the worst impacts of climate change. And so I hope this is a helpful analogy. It's always kind of helped me kind of grok on a little more concretely to something CO2 emissions and odorless, colorless gas, like very hard to conceptualize, I find. So if we remove all that carbon dioxide from the atmosphere, the question then is, where do we put it, right? It has to go somewhere. And I share this image to show that there's a lot of places that carbon dioxide naturally goes. A lot of us are familiar with forestry, the idea that trees breathe CO2 and in that way capture CO2. The ocean is actually the largest carbon sink on the planet. It's absorbed about 25 to 30% of all human caused emissions and actually stores more carbon dioxide than the atmosphere and the land combined. And there are many different ways the ocean captures and stores CO2. And I'll talk a little bit more about the particular way that we're helping the ocean capture additional CO2 safely and durably and storing it for 10,000 years. So our technology is really about working with the ocean and accelerating what it does naturally, which is draw down lots of carbon dioxide. Now, the ocean's capacity to absorb all that carbon dioxide does come at a cost. And it's a cost that Washington State has felt particularly acutely, and it's ocean acidification. This is really an impact of a climate-related impact, a climate change-related impact. And this is really, again, touching back to kind of our dual mission. This is the second half of that mission. How can we improve ocean health in a way that helps mitigate ocean acidification? And in Washington State, 30% of the species in Puget Sound are really vulnerable to acidification. You can see the image kind of on the bottom right there. Acidification corrodes the shells of shellfish. And in Washington, in the early aughts, there was a shellfish die-off, and this is particularly acute in Washington. Washington's a leading provider of farm shellfish in the nation. And so the communities, the businesses, the tribes, everyone who depends on this natural resource really feel this problem. And you can see I have an article here about Washington family opening a hatchery in Hawaii to escape the lethal waters, the lethally acidified waters in Washington. So all of that is, really important context for why Ebb Carbon is investing and operating in Washington State, and really also to acknowledge that Washington State, its communities, industries, tribes are all really looking for solutions to acidification as well. And so that brings us to what we do, which is ocean-based carbon dioxide removal. And what does make our solution really unique is that it does have the capacity to address both of these climate-related issues, excess CO2 in the air and ocean acidification, with a single technology. And as I mentioned earlier, our key insight is that we really need to work with nature and the natural processes, specifically the ocean, to store that excess CO2 safely and durably. So for us, our work is really about unlocking the potential of the ocean to help solve climate change. And so the next couple of slides, I'm going to walk you through kind of a high level overview of how our process works and what our journey has been to date, and where we are today. Okay, so this is obviously a very conceptual diagram, but I use it to try to explain how our process works. And I always like to start by kind of just highlighting there are two main ingredients to our process: low carbon electricity and seawater. And so you can see the seawater kind of on the far left-hand side. It's meant to be those arrows indicating that, we are intaking seawater, and we use low carbon electricity to basically filter it through a series of filters. Um, and the point of those filters is to separate that seawater into an acidic and an alkaline stream. You can think of this as essentially removing the acid from the seawater and returning the alkaline stream of seawater back to the ocean. And the point of returning that alkaline stream, it's really like delivering an antacid to the ocean. It has the effect of immediately reducing the acidity of the receiving water, and it enables the ocean to absorb more carbon dioxide. I can go into more depth on this later if you have questions, at least to the depth of my abilities. But for now, this is the overview of a highly technical process. And I wanted to give you a sense of how we develop our technology and how we are bringing it safely to the real world. And this is really, I like to think of kind of just a little portal into kind of how we bring this innovation to life. And I'll speak to each one of these kind of blips on the timeline here in more detail. But a few things to highlight here. Our approach to carbon dioxide removal is really based on a decade of research by our chief scientist, Matt Eiseman. Um, and the technology that we've been developing, we've been working on this technology since 2021. You're looking at a little miniaturized version. I'll show you the real kind of life-size version on the next slide. And this is kind of, in our labs in our headquarters. And then as we've kind of developed the technology, we've also been demonstrating it. And for us, we've been really intentional about working through public-private partnerships to demonstrate the technology and demonstrate the safety and efficacy of the technology. Which leads us to the third point here, which is piloting it. So the idea of building upon the technology development, the lab demonstration, all that we've learned through those efforts, and then moving to a real world environment so we can start to really see the benefits of the technology in the real world. Okay, so I promised I'd move from that conceptual diagram to the real here. And I just want to give you a sense of what that kind of core technology looks like. I mentioned the process of filtering the seawater and separating it into an alkaline and acidic stream. And this is really that core kind of filter. It's an electrochemical technology. And it's really made up on the left-hand side, you're looking at like a little miniaturized version where we do our kind of testing. And what we're really testing, if you can see the little brown papers, they look like little stacks of paper. I kind of call this the accordion. We're testing those membranes that's essentially the filter. And so after we go through that testing process, we then compile about 200 of those membranes into that larger, fuller size system. I like that photo because it gives you a sense of the scale with all those people in it. So that's really, kind of the core technology. And then if you think of that, we call that the stack on the right-hand side. And then here are about 6 of those stacks all lined up, essentially in the shape of a shipping container. And these we call modules. And these are intentionally actually deployed in shipping containers so they can be easily transported. And this is more kind of what you'll be seeing at project sites. There's kind of these stacks of shipping containers that are really house the core technology. So moving on to the lab demonstration, we talked a little bit about the tech, and this is really oriented towards, talking about the work we've done in the lab. And for the last 2 years, we've been working with leading scientists right there in Colleen County at PNNL SQUIM to really demonstrate our technology, validate that it's safe and effective before taking it to the field. So we've actually installed one fun fact I learned in this journey and joining Ebb is that PNNL SQUIM is the only national lab that has a marine wet lab, marine facilities. So it was the perfect home for us, not only because of that, because of all the expertise in that institution. And so we have installed a system there in the labs, and we've just been putting it through the paces with the scientists there. A lot of different types of work we've done. We've used tanks. That maybe that middle photo looks like tanks. That's not what I mean. I mean bigger tanks, where we have really measured carbon dioxide drawdown after alkalinity, after adding alkalinity to those tanks. The middle photo you're looking at here is where we have done some mesocosm studies. So looking at local biology, exposing them to different levels of alkalinity to really establish safe operating bounds. Where are the limits of alkalinity that we want to avoid in the wild? Because, you know, we've been able to show in the lab that there are limits to that and we can define safety there. We've also been working with modelers. There is a organization, a group that has a Salish Sea model, and really using that model to simulate what alkalinity operations could look like in Squim Bay, and doing all of this in the computer, right? Doing all of this in model space so we can start to kind of understand what the benefits might be for ocean acidification and what the impacts might be. And all of this, of course, is pointed at publishing research that's really foundational for the whole field and can help Ebb Carbon take the next step into the field with a pilot and deploy safely. So I want to take a moment to zoom out and just talk for a minute about why we're focused in Colleen County. And I have covered some of this in the previous slide, just in terms of, you know, the world-class talent here, leading scientists, the only national lab with marine facilities, and that's a huge reason. And I think, you know, being able to study and demonstrate in an area where the ocean environment is well understood, and there's a lot of need for solutions for acidification. It's really a great intersection of kind of need and you know, resources and talent in that sense. There's also, you know, I mentioned our two main ingredients are low carbon electricity and seawater, both of which are in abundance in Colleen County. And you know, there's also just zooming out, looking at Colleen County, looking at the climate resilience plan that Port Angeles has done, looking at the Blue Ribbon panel on ocean acidification. There's interest and will to make progress on these issues, and that's very important to us as well. So which brings me to Project Makoma. This is the pilot project that is scheduled for Port Angeles. And this is really where we're making that move from the lab to the field. This is a temporary small scale pilot. I mentioned in Port Angeles, so just down the road from SQUIM, really great opportunity to build on all the learnings from PNNL. And this is, you know, a first of its kind project. I'm going to orient you a little bit to what you're looking at here. This is a rendering, so this isn't an actual photo. It looks pretty good, but you can probably tell that. But just to kind of orient you to this, if you're looking out at the dock, there is a barge there, and that's really where we intake and outfall seawater. And then the seawater gets pumped to the shipping containers that you see on the shore there. And again, you know, kind of harkening back to that image I showed you of what's inside those containers. That's essentially what's inside those containers. We're processing the seawater there. And then it gets pumped back out to the barge to return to the ocean. Let me see if there's anything else I need to orient you to this here. I think It's important to note too, this is this is a first of its kind project. And so a lot of the work that I've been personally involved with is figuring out how we can tailor the project design to fit this environment and fit this community. So working closely with the port, a local tribe, regulators, all of that has been extremely important to make sure we are um, deploying safely and responsibly.
Where, Kyla, if you go back to that photo, where do you collect the acid?
The acid, let me see if can you see my cursor here? Is it
No.
working? Okay. The acid, I'll just describe it in words. If you can see on towards the right-hand side, there's the stack of logs in the image. And then directly to the left of that, that is where the acid processing and neutralization and storage happens.
Okay. Got it. Thank you.
Yeah. Okay. So I touched on briefly safe and responsible deployment, but it's really kind of everything that went into designing and building Project Macoma. And we really see this as having three main pillars. So the first is permitting and regulatory approvals. So meeting or exceeding all regulations and safeguarding human and environmental health. Ecological safety, and I'll talk a lot more about this. This is something we've spent a lot of time digging into, not only first at PNNL SQUIM, but as we've done our site design, looking at specific site assessments, doing an aquatic vegetation survey, and many other things to really understand the local environment and how we can integrate safely. And then stakeholder engagement. So really making sure we're engaging early, often, and ongoing with a really diverse group of stakeholders so that we can learn from them and meet community needs. So I'll go a little bit more into these in the next slides. First, on the permitting, this is kind of an ugly slide, but just to show you that, there were 10 permits that we've secured across local, state, and federal agencies. I mentioned this is a first of its kind project, and so we actually received a first of its kind NPDES permit from EPA and Department of Ecology to really make sure that our project fully complies with water quality standards and other rigorous protections there. And so we're quite proud of that, achievement. And this process, going through all of these permits, we did public comment periods, did a lot of engagement with local tribes and project stakeholders, and really started the process of engagement quite early on, before we even actually had a particular site that we were focused on, so that we could be building kind of understanding of who we are, what our technology does, so that first of a kind, everyone's kind of doing this for the first time. So we felt that was really important.
Um, uh, how long did it take you to get all those permits, and which one took the longest and which one was the biggest hurdle?
Yeah, good question. It took us about 9 months to get all of these permits.
Okay, not too bad.
Not too bad. I'm actually quite proud of that as well. And I think, yeah, it's a testament to, I think, the potential that folks see in this technology. The one that took the longest, I think going into it, I was thinking probably the Army Corps would take the longest. I think probably the NPDES was the permit that perhaps took the longest, but it was really again about figuring out how to permit a first of its kind within an existing regulation that worked to purpose, but wasn't totally suited to what we were trying to achieve. And just working through all that just took some time.
Yeah, got it. Thank you.
Yeah,
James has a question. James?
sure.
Well, I'm looking at your Department of Fish and Wildlife,
Yeah.
and in your process, what you're doing is you're removing chlorine and introducing and reinserting it back into the water, and you're changing the local chemistry quite significantly before that uh, uh, that disperses, before the alkali and the pH balance disperses across the harbor and out into the water. And so I don't know how you were able to get the Department of Fish and Wildlife to buy off on this chemistry change that would drastically impact the immediate area of where the alkali got put back into the bay. So can you answer that?
Yeah, actually, that NPDES permit from the Washington State Department of Ecology, that's the permit that really, and that's the agency that really looks after water quality, right? And it's under the Clean Water Act, and so they're looking at water quality standards and compliance with those standards. And so they have a very, they have a whole handbook around the NPDES permit with all of the different analyses that you need to complete. And one of which I'll just kind of highlight is called a mixing zone analysis. And so you're really looking at, okay, if we're, introducing that alkalinity into the ocean, what does that look like? How does it travel? What are the impacts and how can we model them? And so that's the process by which Department of Ecology really examines and looks at the potential impacts of any discharge and creates, the permit and compliance around that to make sure that, folks like us are meeting excellent water quality standards at the point of compliance.
How much dilution is there, Kyla, relative to the amount of the alkalinity that you add to the water there at the port?
Can you ask that question in another way?
So is it, if it's an area that mixes that
Yeah.
is, say, a bathtub full, are you adding a cup or a droplet? What kind of example can you provide us?
Yeah, I think I maybe spatially is the best way to think about this. So, at 200 feet away from the outfall, that's where we need to meet by our permit from Department of Ecology excellent water quality standards. And there is there different bodies of water are classified with different kind of labels like excellent, et cetera. And that really determines at that boundary, this is again the kind of like the compliance point 200 feet away, what, for example, pH needs to be within that boundary. And so I should look this up in my notes, but off the top of my head, I believe at that boundary, it is between 7.5 and 8 pH with a human created variance of 0.5. So this is all to say, like, there is a zone of mixing around the outfall, but the point of compliance is really oriented towards making sure we're hitting excellent water quality standards at the edge of it.
Right. So within that, at 50 feet or something, is it kind of a dead zone, or what will that be like right at the outfall?
There's a lot of initial mixing, is what the modeling shows. I can tell you within 30 feet, the pH is within natural variation that you would see in the ocean. And really, what we've done in terms of the design of the system is design it such that there is a lot of mixing as the alkalinity is dispersed. And I'll in my next slide, I will speak a little bit more to some of the ways we're trying to simulate what operations would be like in the real world so that we're doing all of this wayfinding and establishing safe operating bounds so that we have confidence when we start operating, that all of our safety parameters, we've done the checks before we operate. We have the operational protocols to check for safety while we operate, and we have the reporting to Department of Ecology to really create that record of transparency in operations publicly.
Thank you.
Yep. Okay, so let's talk. This is essentially the topic we're just diving into, ecological safety. And so, for us, our philosophy in our technology development and how we deploy this technology safely is go slow to go far. We've really intentionally spent years developing our technology alongside scientists to validate our methods, ensure they're safe, do that kind of wayfinding around what safe operations can look like in the real world. And so for our pilot program, prior to operating, we've done many kind of environmental assessments to really understand local ecology, local environment, and mitigate any potential risks. And during our operations, we have rigorous safety protocols that we follow. And of course, we meet all relevant regulations. So not only are we bringing the research from PNNL to really help inform what those safe operating parameters are, we've also done a lot of site-specific assessments. And so these include things like baselining the water quality there. I mentioned kind of surveying the aquatic vegetation in the area. And I wanted to highlight one of the unique things that we've done, which is what you're looking at here in this slide, really developing a novel study in the lab that's designed to simulate operations in the field, which is granted very difficult to do in a lab, right? The ocean is very different than a flask in a big aquarium, but it's really again to try to figure out where any our safe operating bounds are. So I'll explain a little bit what you're looking at here. What we've done is the flask with the liquid in it, that's actually alkalinity that's been generated by our system at PNNL Squim. And it's being fed into the aquarium in the bottom, or the tub in the bottom. And in that tub, you can see I have a little close up here of some juvenile salmon. We collaborated with a local Indian tribe who donated this salmon for this purpose to really try pulsing in, so kind of simulating that the dispersion of the alkalinity into this tub to see how the salmon react, what impact, if any, it has on the salmon. Because we're really trying to avoid harmful conditions at the project site, and this is one way we really thought we could help answer some of those questions. And so doing this, we had different kind of exposure lengths. The thing I think with salmon particularly is they're highly mobile. And so we simulated what we felt were exposures that, they weren't likely to be like next to the outfall for longer than say 5 minutes, since they're so highly mobile. And so what we were able to see from this testing was that we didn't see any adverse effects on the salmon. And so that gives us a really good signal that the planned operations that we have today, we feel confident heading into them with all of the other safety measures we have in place around, ecological monitoring and making sure we're doing all of the checks while we're operating at the same time. And then the third and final pillar, then I'll turn this over to just a Q&A, is stakeholder engagement. And so, we've been in Colleen County for several years now. Fortunately for us, over at PNNL Squim, we've had the opportunity to chat with lots of different folks, both in Colleen County, statewide, and it's really been to authentically shape what we build. And what you see here are some examples of folks we've worked with. And Melissa, I'm so glad you're joining us today. We're for us, it's a process of listening and building together. And so we have some conversations ongoing where we're really hoping to kind of deliver on some of the benefits that we think we can help add to the community while we're here for this pilot program. Working with Fiera Marine Life Center, they have a sensor, a pH sensor that they're hosting, and we hope to more deeply engage with them to also bring forward some additional educational materials and experiences at the center there. And then with the community boating program, similarly, working on some educational programming with the youth that really use that area for recreational sailing. And then continuing scoping research with a local tribe. That's been something where a really unique opportunity for us to really learn more from the tribe, integrate their knowledge, and hopefully, answer questions along the way that we all have that can all help us better understand the benefits of this technology. So with that, I just want to say thank you again. If this is the first time you've heard from us or heard of us, I hope this is the first of many points of contact that we can have. You have my email there. If you have any questions, you can always reach out. Yeah, and I'll just open it to Q&A. Thank you very much.
Great. Fantastic. So I have questions about, well, first about the acid. Is it a product that you sell, or what happens with that?
Yeah, so it really depends. There are many different uses for the acid that we produce. We've been looking for a couple of different ones. One is remediating alkaline waste. So the concrete industry, for example, has a lot of alkaline waste. This is one way that acid could be used. What we're doing for Project Macoma is we're going to be neutralizing that acid on site with a mineral called brucite. And that's the key thing that we're trying to do there, is ensure that none of that acid returns to the ocean and we're neutralizing it safely. And so for Project Macoma, that's how we're going to be handling most of the acid. And we'll also be exploring some of these other uses for it, like alkaline waste remediation.
Great. And can you talk a little bit about the financial aspect of your business model? I know that you sell into the private carbon credit markets,
Yeah.
but are there other value streams there?
Yeah. So our main product is carbon removal, and there are forward-thinking companies who are voluntarily purchasing carbon removal. Microsoft is an example of them. They're one of our customers because they have made commitments to be net zero, or in Microsoft's case, net negative. And so these are voluntary purchases. And there are some, Microsoft is a good example. There's another organization called Frontier who are really investing in some of these. I mentioned we're a first of a kind, some of these, first of a kind technologies, because they see a lot of potential, and they see their need for carbon removal growing as they look across the horizon for their business. So yeah, that's really our main product.
Okay, great. I saw, was it James? You have another question?
So this one is more a question for you, Colleen, is
Okay.
that uh, Ebb Carbon is going to be producing a lot of acid. And as economic development, this acid is hard to transport. It's in a liquid form. And so in your search for companies that want to move here, the use of this byproduct of Ebb Carbons is is an asset that the community could leverage.
Yeah, so as Kyla was talking, I was thinking about work we're doing called industrial symbiosis, which was created in Denmark, and they have perfected it where they have created industrial parks where one entity is co-located with another that uses the waste streams and creates it and uses it as a feedstock. And they're in some of these industrial parks that they have, like there's virtually no waste from any of the industrial processes, whether it's heat or the water or things like what Kyla's talking about. And so I was going to suggest, Kyla, that you join us or have somebody join us from your team next week in case as we're looking at specifically in the forest products industry and with paper manufacturing and, just the different processes that occur in forest products manufacturing. we want to we're trying to bring everyone together to explore what are their production methodologies and how can we and look at everyone's feedstock streams and waste streams with these experts from Denmark that are coming over to determine how can we use one another's processes to help the next company.
Right, and I think a good example would then be Port Townsend paper. They definitely would consume hydrochloric acid if it's of the right form. The other thing is like a company like Intel and chip vendors would use hydrochloric acid if it's pure enough. And so, can you answer the purity of your off stream?
Yeah, this is certainly not my area of expertise. I can tell you because we are filtering seawater. My understanding is that it's not the highest purity HCl that's coming out the other end. There would need to be some rectification of that. But if you want a more firm answer on that, I can ask one of my technical colleagues for you.
Yeah, that's all right. I've been talking to them already. Hopefully I can be involved in that startup, so
Great.
I'm on their list.
Great.
Perfect. So Jim, you have a question?
I do. Kyla, nice to see you again. That is one of the more lucid presentations of a very complex industrial process that I've ever seen. So well done. Just trying to think about potential barriers to scale as far as expanding the location, the suite of locations where your plant could be located in Washington State, essentially all of them down the Pacific coast. There's starting to be a conversation, at least in the legislature that I've seen so far, about electricity consumption for data centers.
Yeah. Yep.
And I wonder, thinking a year or so down the road, is there a way um, to gather support from communities where you're operating so that you don't get ensnared in that conversation about rationing electricity? Because essentially that's where we're going with this conversation, I think. And so that you don't, so we avoid a potential barrier to scale. I'm not sure exactly what your electricity consumption is, but it is not nearly the same as just a normal household.
Right. Right.
And so react to that if you would, and
Yeah.
tell us how we can help you avoid those regulatory tar pits that you might otherwise encounter.
Yeah, I mean, you've put your finger on, the zeitgeist really, as we've seen kind of the prevalence of AI and just kind of energy demand and projection spiking. I think I mentioned in the presentation that certainly low carbon, specifically low carbon electricity, is one of our main ingredients, and so that is one of the things we just have to have in order to perform our process. The way we think about this is we've always, because our system can turn on and off and is flexible in terms of when we run it, when we need that electricity demand, we've always seen an opportunity for us to help actually provide kind of demand that increases the ability to install and brings new renewables onto the grid. And I think that's something that, we're just going to have to continue to kind of follow the renewables in that sense, and really be advocating for, like I was saying, that bathtub, right? We have to be working on both sides of the equation. We can't do our work without that hard work of decarbonization.
So how many megawatts does the facility use?
On a daily basis, I believe it's about 5 megawatts. So it's like, you can think of that as like a small hotel.
Okay. All right. This has been a fascinating conversation. James, go ahead. You have another question?
Well, I'm really interested in the amount of water you
Mm,
create that's
yeah.
desalinified. Port
Yeah.
Angeles is looking at a water shortage. So if we have a desalinization plant in our area, how much of that water is available for local consumption?
Hmm. Yeah, our process, again, this is a little beyond my technical depth here, but our process does generate a little bit of fresh water. But in terms of the water we're returning to the ocean, it's actually, basically all of the things that were in that water, just with the acid removed. And so it's salty water. It's salty alkaline water that we're returning back.
Well, yeah, I was just looking at that process, and desalinization, which is an interim step because
Yes.
you're separating out the alkaline, and rather than, flushing it out your outflow with the desalinated water, you could potentially bring in more seawater and push it out that way. So
Mm-hmm.
I'm just, we're looking at a water shortfall. So, it'd be nice if your people would consider how we could use that water in our community.
Mhm. Yep. Yep. Point taken. Thank you, James.
So Micah has asked, how's the megawatt usage compared to other industry shops in the port? I know that McKinley, when they were operating, would use about 20 megawatts, but that's, as I understand it, measured per hour. So if Kyla was saying per day 5 megawatts, I assume you take the 5 and divide it by 24. I'm not really clear on that, but that would not be very high relative to what the other tenants use. There's not a big energy user at the port, other than what McKinley used to use. The process of making paper does use a lot of power, the paper mill. And of course, they had a cogen plant as well. So I hope that answers. And Caleb, if you want to add or share anything, happy to have you speak up.
Commissioner McAleer is correct. At this point in time, we do not have a lot of heavy power users. And just to kind of speak to Micah's question directly, what Ebb is looking to use in ways of power, I would definitely say is in the lower half of our tenants. Their consumption of power is not that much. As you can imagine, up at the airport where people are running very heavy machinery, those are usually the consumers of our larger power. And as Colleen said previously, McKinley.
Thank you, Caleb. All right. Does anyone else have any questions for Kyla? All right, I'm not hearing any. So Kyla, thank you so much for joining us today. And it is love to have innovative companies come to Clallam County. We really need more of that. Oh, I see a last question from Paul. What is your dependence on federal funding and involvement and federal government's turn away from climate change solutions? And what are your long-range plans for future development?
Yeah. So, I
Great questions,
understand.
Paul.
Yeah, understand where this question's coming from. So Project Macoma, our pilot, is fully funded by Ebb Carbon, and it's not dependent upon any federal funding. Remind me the other half of the question, Colleen?
What are your long-range plans for future development?
Yeah, I mean, right now we're really laser focused on Macoma, getting it right, right? Learning as much as we can from it, operating safely, and so that's the team is just laser focused on that. In terms of how we grow, where we expand, we're also really interested in exploring partnerships with James, as you were kind of putting your finger on desalination partners, because we're looking at partners that already process lots of volume of seawater, and thinking how we might be able to integrate and tap in and really similar to kind of what you were mentioning, Colleen, before, using kind of a waste product as a feedstock, which is an opportunity within the desalination industry because they produce a brine and then discharge that. So that's kind of, one of the ways we're thinking about potentially scaling the technology in the future.
Okay, terrific. Thank you. Well, Kyla, I'll get a hold of you about the industrial symbiosis meeting that we're having, and hopefully somebody can come in person. We've got all the local industrial companies going to join us next week. So I hope you will be able to send somebody.
Wonderful.
And
Thank you.
yeah, absolutely. All right. With that, I'm not seeing any other questions, and it is 8:52. So we will call it a morning. Thank you again so much for sharing the journey and the intentions of Ebb Carbon. And we wish you the very best success, and let us know if there's anything we at the Clallam EDC can do to help.
Wonderful. Thank you so much for having me. Pleasure to be here. Thanks for everyone's time.
Thank you. Right.
Hey,
I got
Colleen.
booted off right at the last minute. Yeah.
Can you explain more about this industrial symbiosis discussion that's happening next week?